Hi everybody. Today I am discussing the differentiation of parametric functions which carries 3 marks in your PU board exams. So what is this parametric functions? Let us know more about this parametric functions. Expressing x and y in other variables, those functions are called as parametric functions. For example, if x is equals to cos theta, y is equal to sin theta, see there we are expressing the functions in terms of theta. So that theta itself becomes the parameter. So these type of questions are called as, or functions are called as parametric functions. Functions. Parametric functions means expressing x and y in terms of other variables. For example, see here x is equals to 1 by t, y is equals to tq. Observe this. I am expressing x in terms of t, y in terms of t. So this is what the parameter. Which one? T. T is the parameter. So expressing x and y in terms of other variable is called as parametric functions. I will give you one more example. If x is equals to cos theta, y is equal to sin theta. See here we are expressing x and y in terms of theta. The parameter is theta here. Okay. So these type of functions are called as parametric functions. So here what the question they will give is they will give x and y. Okay. So after giving, they will ask to find out dy by dx. So let us consider the question what I have written there. X is equals to a into theta plus sine theta. Okay. Y is equals to a into 1 minus cos theta. I have considered x and y. See, observe in both x and y, the parameter is theta. So we must differentiate x and y both with respect to theta. So let us differentiate x with respect to theta. So if you differentiate x with respect to theta, obviously we must write that as dx by d theta. Be careful, dx by d theta. A is a constant. Keep that constant as it is. Theta, as we are differentiating with respect to theta, derivative of theta is 1 plus sine theta derivative is cos theta. See, this is dx by d theta. Again, let me differentiate y with respect to theta. So, dy by d theta is equals to a constant, keep that constant as it is. 1 derivative is 0 minus cos theta. Cos theta derivative is minus sin theta. Okay. So now what we can do? Simplify this. Minus into minus it is plus a sin theta. It is dy by d theta. So what is the question? They have asked to find out dy by dx. Isn't it? So dy by dx. Let us find out dy by dx. dy by dx is equals to what we see. Observe this properly. Dy by dx means here we have dx by d theta as well as dy by d theta, isn't it? So be careful. We want dy by dx. So dy by dx is equals to divide both numerator and denominator by d theta. Then it becomes what? Dy by d theta divided by dx by d theta. So we know dy by d theta, that is a sin theta, by dx by d theta is a into 1 plus cos theta. See, both will get cancelled. Sin theta by 1 plus cos theta we have got. But the question what they have asked is we should prove it has tan of theta by 2. Isn't it? So to prove this as tan of theta by 2, apply the formula, half angle formula for sin theta. See, actually, multiple angle formula is what? Sin 2 theta is 2 sin theta cos theta. But we want half angle formula. So half of that. Sin theta is equal to 2 sin theta by 2 cos theta by 2. Similarly, we know the multiple angle formula for cos 2 theta in terms of cos is 2 cos square theta by 2 minus 1. So take this one to left hand side. It becomes 1 plus cos 2 theta. Observe there, I will apply. Just a second. I should consider the half angle formula. Okay. So that is what I am doing here. Cos theta is equal to 2 cos square theta by 2. So 1 plus cos theta is equal to 2 cos square theta by 2. So next, substitute everything. 2 sin theta by 2 cos theta by 2 whole divided by 2 cos square theta by 2. 2 gets cancelled and one cos function will get cancelled. So the remaining is sin theta by 2 divided by cos theta by 2. So sin theta by 2 cos theta by 2 is tan theta by 2. So this is what they have asked to prove. I will move to the second question. If x is equals to a into theta minus sin theta, y equals a into 1 plus cos theta, then show that dy by dx equals minus cot of theta by 2. So here, even in this question, this is same as the previous problem. Okay, we have to find out the derivative. That means dy by dx we have to find out. Here the parameter is theta. We should differentiate the function with respect to the parameter, that is theta. So let us do this problem. X, just I'm writing the question. X is equals to a into theta minus sine theta. Y is equal to a into 1 plus cos theta. So now I will differentiate this with respect to x. Sorry, with respect to theta. Differentiate with respect to theta. So dx by d theta is equals to a constant. Keep that constant as it is. Theta derivative is 1. Sin theta derivative is cos theta. Similarly, I will differentiate y with respect to theta. So what you will get? Dy by d theta is equal to a into 1 derivative is 0, cos theta derivative is minus sin theta. See, we have got dx by d theta and dy by d theta. Let us find out dy by dx. As you know, dy by dx can be written as dy by dx is equal to dy by d theta divided by dx by d theta. So we know dy by d theta, that is minus a sin theta divided by a into 1 minus cos theta. See there, a constant, it will get cancelled. Okay, sin theta, for sin theta, I will apply the half angle formula 2 sin theta by 2 cos theta by 2 whole divided by. See, we know in the previous problem we had 1 plus cos theta. For 1 plus cos theta, we wrote. See, you please always remember 1 plus, if it is plus, it is 2 cos square theta by 2. If it is minus 1 minus cos theta, then the function is in terms of sine, that is 2 sine square theta by 2. So just write down that formula. Okay, whichever term will get cancelled, you just cancel it. 2 and sine function will get cancelled. Remaining is cos of theta by 2 divided by sine of theta by 2. Cos of theta by 2, cos by sine, it is, sorry, negative is there. You please don't forget to write the negative. So the negative minus cot of theta by 2. So this is what they have asked in the, okay. So this is the final answer. I think you have got this question. So let us start with the third question. If x is equals to a into cos theta plus theta sin theta, y is equal to a into sin theta minus theta cos theta, find dy by dx. They have asked to find out. Even in this problem also, they have asked to find out dy by dx. But in the previous problem, they were asking to prove. Okay, but here just dy by dx they have asked. So let us write down the function. Let me differentiate. See, actually, in this question, the parameter is theta. So we must differentiate x and y with respect to the parameter theta. Okay, the parameter is theta. So x is equals to a into cos theta plus theta sin theta. Y is equal to a into sin theta minus theta cos theta. So let me differentiate this with respect to theta. Okay. So dx by d theta is equal to a into cos theta. You know the derivative of cos theta is minus sin theta. And in this question, you are having product of two functions. See, theta is one function, sin theta is another one function. We must apply the product rule for this. So if you apply the product rule, first function into, that is theta into sin theta derivative is cos theta plus sin theta second function into derivative of first function, that is 1. So observe this properly, very simple thing. In the first term, we are having minus sine theta plus the second term is theta cos theta. The third term is plus sine theta. See there, plus sine theta minus sine theta, it will get cancelled, isn't it? So just I will cancel these two. So if you cancel that, what you will get actually? Let us find the final answer. The final answer is a into theta cos theta. Okay. Now I will differentiate y with respect to the parameter theta. So let us differentiate with respect to theta. Dy by d theta is equal to A is constant, keep that as it is. Sin theta derivative is cos theta. See here in this question, minus, you keep that minus as it is. Now, why I am keeping that? Because if you apply the product rule, you will get two terms, isn't it? So you must consider the negative for both the terms. That's why better you keep the negative as it is and put a bracket while differentiate before differentiating. Theta as it is, I will write down first function. Cos theta derivative is minus sin theta plus cos theta into derivative of sin theta is 1. So now what I will do here, a into cos theta as it is I am writing minus. See, if you consider minus to both inside the bracket, what you will get? Plus theta sin theta minus cos theta. So plus cos theta minus cos theta, both will get cancelled. I will write down the remaining terms, that is a into theta sin theta. So finally, dy by dx, that is what they have asked. So what we have got here, dx by d theta, this is, okay, this is what? Dy by d theta, substitute over there. So dy by dx can also be written as dy by d theta divided by dx by d theta. So that is equal to a into theta sin theta divided by a into theta cos theta. See, a theta, both will get cancelled. Sin theta by cos theta, it is tan theta. Okay, I think you have got this. See, actually, this is for 3 marks. If you differentiate x with respect to theta and if you get dx by d theta, you will get 1 mark. Similarly, differentiating y with respect to theta, if you get dy by d theta correctly, you will get one more marks. So finally, if you substitute in the place of dy by d theta and dx by d theta, and you have got the final answer correctly, you will get 3 marks. So this is actually the parametric functions consisting of 3 marks. Okay, the fourth question is, if x is equals to square root of a power sine inverse t, y is equals to square root of a power cos inverse t, then prove that dy by dx equals minus y by x. See, if you see the question first, you may feel it is very difficult, but this question is very easy and easily you can get 3 marks in this question. So, how to solve this? Let us see. Consider the x. X is what? A to the power of sine inverse t. Y is equals to, y is equals to what? Y is equal to a to the square root of a power cos inverse t. Okay. Now what you should do, you consider the first function, that is x as first function and y has second function. Now multiply 1 and 2. Multiply 1 and 2. So let me multiply. I will multiply left hand side with the left hand side. So what you will get? X into y is equal to, multiply the right hand side with the right hand side. A square root of a power sine inverse t into square root of a power cos inverse t. See, actually, in between this, we are having multiplication symbol, isn't it? So as we are having multiplication, we can take both the function in a single root. If we, instead of multiplication, if you had any addition or subtraction symbol, you can't take like that. Okay, so just I am writing within a single root, that is a to the power of sine inverse t into a to the power of cos inverse t. If the base are same, we know what we can do, we will add the powers, isn't it? So that is what I will do here, I will add the power. So let us see what we will get. So if you add the power, it becomes a to the power of sine inverse t plus cos inverse t. In inverse trigonometric function, you know this property. What is that? Sine inverse x plus cos inverse x is always equal to pi by 2. Isn't it? So that property I will apply here. So the power can also be replaced as a to the power of pi by 2. The parameter t will vanish here. See this. Okay. See, till this step I have not differentiated the function. Now I will differentiate this with respect to x. So continue there. Okay, differentiate with respect to x, dy by, sorry, while differentiating in the left hand side, what we are having? X into y. X into y means it is a product of two functions, isn't it? Apply the product rule. X into y derivative is dy by dx plus y into x derivative is 1. That is equal to the right hand side, what we are having? Square root of a power pi by 2. It is a constant. Constant derivative is 0. So x into dy by dx. Take this y to right hand side, it becomes minus y. So finally, dy by dx is equal to minus y by x. So this is what the final answer. Next, the fifth question is, if x is equals to sine t, y is equal to cos 2t, then prove that dy by dx equals minus 4 sine t. Let us prove that. Okay. So to prove that, consider x and y. Here the parameter, what is the parameter? T. So we must differentiate both x and y with respect to t. X equals sine t, y is equal to cos 2t. So I will differentiate x with respect to the parameter t. So be careful, okay? So if you differentiate x with respect to the parameter t, it becomes dx by dt. Sin t derivative is cos t. Similarly, I will differentiate y with respect to t. So dy by dt is equals to cos 2t. Derivative is minus sin 2t into chain rule one after the other. See, first I differentiated the function. Now I will differentiate 2t. 2t derivative is 2. Okay. So what we want actually? We want dy by dx. So dy by dx is equals to dy by dt divided by dx by dt. So dy by dt is minus 2 sine 2t divided by dx by dt is cos t. See, actually, what we have to prove, dy by dx is equal to minus 4 sine t. So in the numerator, we are having sine 2t. So multiple angle formula. Okay, sine 2t can be written as 2 sine t cos t whole divided by cos t. Cos t, both will get cancelled. Okay, so the remaining is minus 4 sine t. So this is what actually the final answer. I will move to the sixth question. If x is equals to a into cos cube theta plus y and y is equals to a into sine cube theta, then prove that dy by dx is equals to minus cube root of y by x. This is what the question, isn't it? So see the question properly. A cos cube theta, x they have given. What is the parameter here? In this, the parameter is theta, isn't it? So you must differentiate x and y with respect to the parameter theta. Let us take down the question, that is x is equals to a cos cube theta, y is equal to a sin cube theta. Now I will differentiate with respect to theta. Okay. So what we will get? Dx by d theta is equals to a constant, keep that as it is. Cos cube theta derivative is 3 cos square theta into power is over. Now we should differentiate the function cos theta. Cos theta derivative is minus sin theta. Okay. Finally, minus 3a sin theta into cos square theta. This is dx by d theta. Okay. Next, I will differentiate y with respect to the parameter theta. Okay. So dy by d theta is equal to a constant. Sin cube theta is 3 sin square theta into, then observe there, power is over. Now sin theta derivative is cos theta. Now let me find out dy by dx. Dy by dx is equals to dy by d theta divided by dx by d theta. So dy by d theta is 3a sine square theta into cos theta whole divided by minus 3a sine theta into cos square theta. Isn't it? So now, see which will gets cancelled? 3a gets cancelled. Okay, one sine theta gets cancelled and another one cos theta will gets cancelled. Remaining is what? Sine theta by cos theta. Sine theta by cos theta is what? Tan theta. Consider this as equation 1. Why we should consider this as equation 1? Because they have asked to find out dy by dx has minus cube root of y by x. So now I will consider minus cube root of y by x. Consider minus cube root of y by x minus cube root of y. What is y actually? Y is a sine cube theta by a cos cube theta. A gets cancelled, isn't it? Sine by cos, it is what? Tan cube theta. It is cube root actually. Okay. Cube root means what? The power is 1 by 3. See, tan cube theta as it is, I have written whole to the power of 1 by 3. This 3 gets cancelled with this 3. So that is equal to minus tan theta. See, even here also we will get negative. Okay. See, consider this as equation 2. So final conclusion is from 1 and 2, from 1 and 2, dy by dx equals minus cube root of y by x. That's all. I think you have got this. If you have any doubts regarding this, you can put in the comment box. And also you please subscribe my channel, share, like the channel. Okay. Thank you.